Good afternoon, students. Today we discuss the chapter Environmental Chemistry in APMCET or TSMCET. That weightage of chapter is one question. Mostly that question is related to easy one. Either it may be a single question or it may be a matched question. Okay. The topic is environmental chemistry. First of all, we go to what is meant by environment. Environment is nothing but everything that is present surrounded us. Let us take air, water, soil, whatever it may be that is present around, that indicates environment. Okay. So first of all, we must know about the environmental segments. Environmental segments. Here, that environmental segment divided into four types. Number one, atmosphere. Environmental segments are divided into four categories. One is atmosphere. Second one is hydrosphere. Third one is lithosphere. And fourth one is biosphere. So here environmental segment are divided into four categories. One is atmosphere, second one is hydrosphere, third one is lithosphere, fourth one is biosphere. Atmosphere. That atmosphere contains that blanket of air. That air contains so many number of gases like nitrogen, oxygen, oxides of sulfur, nitrogen, carbon, like that. So atmosphere protect that earth as a blanket, because these gases will create environment. Hydrosphere, that is related to oceans, seas, rivers, streams, groundwater. Everything is related to hydrosphere. That hydrosphere will be occupied on the surface of the earth. That hydrosphere contains oceans, seas, rivers, streams, groundwater, glaciers, so on. And the third one, lithosphere. That lithosphere is the solid mantle of the earth which contains rocks, hills, that solid mantle of earth. Solid mantle of the earth. So here that lithosphere contains rich source of minerals. So we know the importance of the minerals in nature. Most of the metals will be extracted from the minerals, so which will be available on lithosphere. And the fourth one, biosphere. All living organisms like human, animals, everything will be included in biosphere. So here that biosphere will contains all living organisms like human beings, animals, and everything. Here that biosphere is interlinked with all other three environmental segments. If there is any changes that can be that can be takes in these three regions, that will be ultimately affected by the biosphere. So initially everyone must idea about environmental segments. Here all four environmental segments will be definitely known in this environmental chemistry. Among all these, we go to explanation about atmosphere. Again, that atmosphere is divided into 4 categories. Actually, that atmosphere is ranging from up to 500 kilometers from the surface of the earth. Up to 500 kilometer region is said to be atmosphere. Again, that atmosphere can be divided into 4 categories. Number 1, troposphere. First one is troposphere. Second one, stratosphere. Stratosphere. Third one, mesosphere. And fourth one, thermosphere or ionosphere. Thermosphere or ionosphere. So all these 4 categories are present in atmosphere. That atmosphere is the layer up to 500 kilometers region from the surface of the earth. So in this 500 kilometers region, from 0 to 10 kilometers region is said to be troposphere. From 10 kilometer onwards to 50 kilometers, that region is stratosphere. From 50 kilometers to 85 kilometers distance, that is mesosphere. And from 85 kilometers to 500 kilometers region is thermosphere or ionosphere. Thermosphere or ionosphere. So out of these 4 regions, the first thing is troposphere, which is the main region of the atmosphere, which helps to existence of the life on the earth, because that troposphere will protect as a blanket, because already we said nitrogen, oxygen and various gases are present in this region. That's why troposphere is the main region to the human being for the existence of life. And the second one, stratosphere, ozone is present. Ozone is present. So everyone must has an idea about ozone, because ozone which prevents the fall of UV region to the earth, because that ozone absorbs those radiations which came from the sun, that is UV region, high energetic region. Those high energetic region is absorbed by the ozone layer. So that ozone layer is present in stratosphere mainly at a distance of 10 kilometers region to 50 kilometers region. So in that region ozone is present. That ozone will absorb that harmful radiations which are coming from the sun radiation, mainly ultraviolet radiations. So ozone will absorb UV radiations. Absorbs UV radiations. Actually, those UV radiations are high energetic. Already that part we have learned in a atomic structure chapter. And coming to the mesosphere, that mesosphere, that various radiations will be present here. In that, mostly that radio frequencies are observed. Whereas in case of thermosphere or ionosphere, that gases will be ionized. Let us take nitrogen gas, oxygen gases will be ionized at this temperature. So high temperature will be noted in a thermosphere or ionosphere. So that is about 85 kilometers distance to 500 kilometers distance. So initially we have a knowledge of these classification. That atmosphere can be divided into 4 categories. After that, coming to the lesson, in this, first of all, some definitions and terms are there. So that definitions and terms about environmental chemistry. In that, various definitions are there. Among them, first one is pollutant. Pollutant. So pollutant, it is the material that is already exist in nature, but its quantity increases due to human activity. So any substance that is naturally present in atmospheric air, but its quantity is grown due to human activities, that is said to be pollutant. For example, carbon dioxide. Carbon dioxide is a pollutant. Why? Because naturally 0.03% carbon dioxide is available in nature. That means already carbon dioxide is available in nature with 0.03%. But nowadays, due to industrialization, especially cement industries, that carbon dioxide level increases. Carbon dioxide level increases. That's why it causes harmful effects to the environment. So we said to be CO2 is a pollutant. So pollutant is a material that is already existing in nature, but its quantity increases due to human activity. That is said to be a pollutant. Coming to the second one, contaminant. Contaminant. So contaminant is the material that is not available in nature. So the material which is not available in nature but exists due to or arises due to human activity, that is said to be a contaminant. For this, the best example is MIC, methyl isocyanate. That MIC is abbreviated as methyl isocyanate, CH3NCO. This is the formula of methyl isocyanate. Actually, that methyl isocyanate is not present in nature, but it is prepared purely our utilization. Actually, this gas is released in 1984, Bhopal. That's why you call it as Bhopal gas tragedy. So many people were died and affected still this because of methyl isocyanate. So contaminant is the material which is not present in nature. Contaminant is the material which is not present in nature, but it is released into atmosphere due to human activity. So such type of materials are said to be a contaminant. So what is the major difference between the pollutant and contaminant? So here pollutant is available in nature, but its quantity increases due to human activity. Whereas contaminant is the material that is not present in nature, but it is released due to human activity. Okay, that is the major difference between a pollutant and a contaminant. After that, we go to another definition, that is dissolved oxygen. So everyone has idea about dissolved oxygen, because that aquatic life existence in water is due to dissolved oxygen. Dissolved oxygen we can represent as DO. So that survival of aquatic life in water is due to dissolved oxygen. So that surface water contains more amount of oxygen, because in presence of sunlight, that oxygen will be dissolved in the surface water. That is useful for the existence of aquatic life. Here, that pure sample of water contains 4 to 6 milligram per liter. That pure water 4 to 6 milligram per liter or ppm, parts per million, of oxygen in water. If that water level contains less than this amount, that means 4 to 6 milligram per liter is not present, or less than 4 milligram per liter, that water is said to be polluted water. So here that pure water sample contains 4 to 6 milligram per liter of oxygen, that is useful for the survival of or existence of aquatic life. Generally, polluted water has lower DO value. that polluted water sample has lower DO value. Polluted water sample has a lower DO value. After that, speciation. That speciation is the method of classification of pollutant. Another definition is speciation. That speciation is nothing but classification of pollutant. Classification of pollutant. Whether it is organic pollutant or inorganic pollutant or inorganic pollutant. Organic, inorganic pollutant. So, speciation is the method of the classification of pollutant, whether it is maybe organic pollutant or inorganic pollutant, or in some cases organometallic also. Organometallic pollutants. And one more important definition, that is receptor. Receptor. Receptor is nothing but the medium which is affected by the pollutant is said to be receptor. Receptor is nothing but medium affected by the pollutant. Medium affected by pollutant. For example, while we are moving in a traffic, our eyes are receptor. Why? Because if we are stuck in a signal center, then that carbon monoxide will be released from the various vehicles. At that small instant, that carbon monoxide will affect our eyes. That's why our eyes are receptor. And it is a short exposure. Short exposure. Because we are exposed to that pollutants only within 10 minutes or within 5 minutes. That's all. That's why receptor is the medium which is affected by the short-lived pollutant is nothing but a receptor. And one more thing, sink. There is a similarity between the sink and receptor. First of all, we must know about the sink. Sink is nothing but medium which is affected by the long-lived pollutant. Medium affected by long-lived pollutant. Long-lived pollutant. The medium which is affected by the long-lived pollutant. For example, seawater. That seawater is a sink for CO2. Seawater is a sink for CO2 because that atmospheric CO2 is always in contact on the surface of the water. That's why that CO2 is always in contact with the seawater. So, seawater is a sink for CO2. And the second example, that dried leaves will be merged on the surface of the soil. That surface of soil is a sink for dried leaves. Surface of water is a sink for dried leaves. Okay. And one more thing, that microorganisms act as a sink for dead animals. So those dead animals will be destroyed by the microorganisms. So these are the examples for sink. So what is the similarity between the sink and receptor? So both will be the provided the surface, but receptor is a only short lived or within a short time, whereas sink is a long lived pollutant. Okay, so these are the best examples for sink. After that, we go to another example, that is chemical oxygen demand. Chemical oxygen demand, in shortcut we can write as COD, chemical oxygen demand. Chemical oxygen demand, it is a measure for measuring the purity of water. Purity of water. What is meant by chemical oxygen demand? So here chemical oxygen demand is nothing but the amount of oxygen required for the oxidation of organic matter present in the water sample. So COD is the amount of oxygen required, amount of oxygen required to oxidize organic matter present in water sample. Generally water sample will be more polluted, then definitely it requires more amount of oxygen. So here that amount of oxygen is measured by using COD. So here that chemicals used are acidified potassium dichromate. So here while calculating the COD of a sample, acidified potassium dichromate is used. Acidified potassium dichromate is used. So here that acidified potassium dichromate, mostly we can use 50% sulfuric acid as a medium. 50% sulfuric acid, H2SO4, is used for the acidification. So here that chemical oxygen demand is the method of measuring the quantity of oxygen that will be needed to oxidize the organic matter present in the water sample. Okay, so here we are testing the purity of water. For example, if different samples will be analyzed, let us take samples A, B, C, D. Let us take samples A, B, C, D. Here that COD values are, for that sample COD values are 10 ppm, 20 ppm, 30 ppm and 50 ppm. Among all these samples, which sample is required more amount of oxygen? That is that sample D, 50 ppm is required, is more oxygen is required. Less amount of oxygen is required in first case, only 10 ppm. So more amount of oxygen is required means that sample is more polluted. So here that 50 ppm sample is more polluted because more amount of oxygen is required. Whereas in case of A, less amount of oxygen is required, that means less polluted. So here the order of COD values are from A to B are highest amount will be required for D and lowest amount is required A. So here higher the BOD value, higher the COD value. Actually BOD values are not calculated up to now. Now further we go to the BOD calculation. At present COD calculated, then higher the COD value, more polluted, lower the COD value, less polluted. So after discussing the BOD also, we can go to the comparison. So this is about the chemical oxygen demand. After that, another example is definition BOD, biochemical oxygen demand. BOD, biochemical oxygen demand. Biochemical oxygen demand. So actually this is a 5 days process and is carried at a temperature of 20 degrees centigrade. So this process is carried out at 20 degrees centigrade and 5 days process. So here the samples who's analyzing the BOD value are treated with acidified potassium dichromate. Here also acidified potassium dichromate. K2Cr2O7. Acidified potassium dichromate is a reagent. So those samples which are analyzed for BOD value are taken to that acidified potassium dichromate is added at a temperature of 20 degrees centigrade and the samples are stored 5 days. After that analyzing we get the BOD values. So here also higher the BOD value, more the pollutions, more the polluted sample. So here we can identify that a given water sample is more polluted or less polluted by using two ways. One is BOD and the other one is COD. So higher the BOD value, more polluted, or higher the COD value, more polluted. Lower the BOD value, less polluted, or lower the COD value, less polluted. So here that order of polluted sample will be related to the BOD value. Okay. So a pure sample of water has, now let us go to the conclusion. So this conclusion is very important. A pure water sample has number one, higher dissolved oxygen, higher DO value, higher dissolved oxygen, because more amount of oxygen will be dissolved, then the water sample is good. Coming to the COD and BOD, second one, lower COD value, because COD value is the measured value which is obtained by adding potassium dichromate, acidified potassium dichromate, which provides the oxygen. So more amount of oxygen it is utilized, then that higher value of COD will indicate so more polluted. If less amount of oxygen is utilized, then it has lower COD value. Less amount of oxygen utilized means the water sample is a good sample. That's why a pure water sample has higher DO value. Second thing is lower COD value. And the third one is lower BOD value. Lower BOD value. Okay. So here a pure water sample is considered, then its DO value is high, its COD value or BOD value is low. If polluted water sample is considered, then the quite opposite will be observed. That means a polluted water sample has lower DO value, higher COD value and higher BOD value. After completion of this, one more definition is left, that is threshold limit value. Threshold limit value. That threshold limit value is indicated by the symbol TLV. Threshold limit value. Actually, that toxic nature is inversely proportional to TLV. Let us go to the explanation. What is meant by threshold value? Here, when a person is continuously exposed to an industrial area up to 7 to 8 hours continuously, absolutely is exposed to the pollutions continuously. Up to that, what level its body is supported for against the pollution is said to be threshold limit value. If that limit will be crosses, then the person will be severely affected. That he will be affected by the pollutant. So that's why he will be. So threshold limit value is nothing but the maximum permissible level of the pollutant that a person is exposed to continuously 7 to 8 hours. Then absolutely his body is affected by the pollutants. That's why he will be go to sick because of that permissible level of the toxic levels will be crosses. So the maximum permissible level will be affected by the pollutant by the person is nothing but a threshold limit value. For this, we go to an example of different samples A, B, C has different TLV values. TLV values. For example, that TLV value for 4 samples are for different gases. One is 1 ppm, 3 ppm, 5 ppm, 7 ppm. What is the meaning of this threshold limit value? For example, coming to the last one, if that D has 7 ppm, that means a person is exposed to that toxic gas up to 7 ppm, he has no health hazards. He has no health hazards. So high level of toxic level will be present in the atmosphere, then the person cannot be affected. If its level crosses 7 ppm, ultimately the person is affected by the pollutant. So here first gas has only 1 ppm is the permissible level. TLV is nothing but permissible level. Permissible level. That permissible level of pollutant to the person is only 1 ppm. If it crosses 1 ppm, absolutely that gas will cause health hazards to that person. So when you compare that pollutant A and pollutant B, which is more harmful is nothing but A is more harmful. Only because 1 ppm is permissible in the atmospheric air. After crossing 1 ppm, that will be adversely affect to the human being and causes health hazards. Whereas in case of D, maximum permissible level is 7 ppm. Up to 7 ppm, it cannot cause any harmful nature to the person. That's why D has a higher TLV value. So coming to the relation, toxic nature is inversely proportional to TLV. So out of these 4 gases or 4 pollutant, which is more toxic? 1 ppm is the more toxic gas. 1 ppm is a more toxic gas. Whereas less toxic gas is D, sample D, less toxic. That's why initially we can write that toxic nature and TLV both are inversely proportional to each other. Toxic nature and TLV both are inversely proportional to each other. సో ప్రతి ఒక్కరికి కూడా డెఫినెట్గా ఈ టర్మ్స్ అనేవి తెలియాలమ్మా. సో దీస్ టర్మ్స్ రిలేటెడ్ క్వశ్చన్స్ ఆర్ ఆల్సో ఫ్రీక్వెంట్లీ ఆస్క్డ్, మోస్ట్లీ that TLV and BOD, COD and dissolved oxygen. Here there may be some calculations are also there. How to calculate the COD and BOD. While calculating the BOD and COD, we can use acidified potassium dichromate is a reagent. So we know the relation that 49 grams of potassium dichromate, 49 grams of potassium dichromate liberates 8 grams of oxygen. This is the relation we can use during the calculation. So while calculating the BOD or COD, the main chemical reaction takes place between the potassium dichromate and the pollutant. Here that potassium dichromate releases oxygen based on the equivalent weight 49 grams of potassium dichromate that liberates 8 grams of oxygen. From this we can calculate the BOD or COD as by using the formula BOD or COD, that is equal to that milligrams of oxygen divided by that volume of the water in liters. So by using the formula we can calculate that BOD and COD, which is obtained in parts per million ppm. So here we can calculate that weight of oxygen by using the relation 49 grams of potassium dichromate that will liberate 8 grams of oxygen. So from this we can calculate the how much amount of oxygen will be liberated. Now we can use that milligrams of oxygen. That means the weight of oxygen is expressed in milligrams and volume of the water sample must be taken in liters. Then we get a value of BOD or COD in each units parts per million. Okay, so this is about conclusion of BOD and COD along the definitions. So in this chapter, definition is the one of the important priority. So in most of the cases, previous years, that questions are also frequently related to the TLV and BOD and COD. After that, in this chapter, we go to the different kind of pollution. So here, that pollution is of different types. One is atmospheric pollution. Second thing is water pollution. Third one is soil pollution. Along that, one more is also there, that is sound pollution. Actually, that sound pollution is not related in your chapter. Only atmospheric pollution, water pollution, soil pollution. All these three learn in this chapter. That fourth one is the sound pollution, that is beyond our limit. So only we learn three kind of pollutions, that is atmospheric pollution, second one is water pollution, third one is soil pollution. Coming to one by one. So here that atmospheric pollution is mainly due to two kind of ways. One is gaseous pollution. Second thing is particulate pollution. So here atmospheric pollution is of two types. One is gaseous pollutants, second one is particulate pollutants. Mostly that gaseous pollution is due to that oxides of carbon, nitrogen, sulfur. Along that hydrocarbons. Whereas that particulate pollutant is due to mist, that dust, smoke, smog like that. So here that atmospheric pollution, actually that atmospheric pollution mainly we call it as air pollution. Okay, that air pollution is mainly one is gaseous pollutants and another one is particulate pollutant. Mostly that gaseous pollutants are oxides of carbon, nitrogen, that hydrocarbons, along that CFCs, everyone must have chlorofluorocarbons, and ozone also one of the gaseous pollutant in troposphere. Whereas particulate pollutants are mist, dust, smoke, smog like that. So now we go to one by one. First of all, gaseous pollutants. In that gaseous pollutants, coming to the oxides of sulfur. Oxides of sulfur. Actually, that sulfur in the form of oxides like SO2 will be released in the atmosphere due to burning of fossil fuels. So, whenever that burning of fossil fuels, that sulfur will be oxidized to sulfur dioxide. Again, this sulfur dioxide will be oxidized to, because of the particulate pollutants, it gives sulfur trioxide. So, in this way, sulfur dioxide and sulfur dioxide, both oxides will be which type of pollutants? Gaseous pollutants. So, those gaseous pollutants will be more effect on human being, especially that animals are human being. For example, sulfur dioxide. The presence of sulfur dioxide will causes respiratory disorders. That respiratory disorders will be mainly due to the presence of atmospheric sulfur dioxide. So here that sulfur dioxide actually somewhat will be liberated due to the volcanic eruptions. Along that sulfur dioxide in atmospheric air produced by heating of or by burning of fossil fuels, that liberated sulfur dioxide will affect the respiratory disorders on human being. So here that smooth tissues which are present in the respiratory tract will be affected, especially that mucous membranes will be affected by sulfur dioxide. So this will be happened in humans and animals. Whereas in case of that plants, that aging of buds, aging of buds. So that aging of buds, so that flowering will not be takes place due to the presence of sulfur dioxide, because that atmospheric level CO2 is high or low, even low level, it will be cut off the buds from the plants. So that is the adverse effect observed in the plants. The same thing will be happened in presence of sulfur trioxide also. It can be also causes mainly sulfur trioxide will cause the respiratory disorders in human beings. So this is about the oxides of sulfur. After that, coming to the second one, oxides of nitrogen. Especially that oxides of nitrogen. Let us take NO and NO2. Actually, under normal condition, nitrogen does not react with oxygen. So everyone has an idea about that non-reactivity of nitrogen with oxygen under normal conditions, because that triple bond between the nitrogen is very stable. That's why the bond breaking will be difficult. So under normal condition, the triple bond cannot be broken by the ordinary temperature. That's why no reaction at normal condition. But whenever these gases are present in the atmospheric air, actually 78% of nitrogen will be present in the atmospheric air and 21% of oxygen will be atmospheric air. These two gases will combine to give oxides of nitrogen while thundering. So while during the fall of rain, thunders will be obtained, very high temperature will be liberated. At that temperature, that will produce NO and NO2 during thundering. So In this way, nitric oxide and nitrogen dioxide will be liberated in atmospheric air. So here there is a adverse effect of nitric oxide in atmospheric air, because in stratosphere ozone is there. That stratosphere ozone will be depleted by the nitric oxide and produce NO2 and O2. That level of ozone will be decreases in stratosphere due to the presence of NO. And another way of release of NO is from supersonic jet planes. NO is also released. NO is also released. NO is also released in atmospheric air. From supersonic jet planes. Supersonic jet planes. So these supersonic jet planes will fly at a high level. So beyond that level, that liberated NO will reaches the stratosphere. So the liberated NO will damage the ozone. That's why ozone level decreases in stratosphere. So this is the adverse effect observed by nitric oxide, that is nothing but oxides of nitrogen. And one more important thing, that is coming to the carbon. సో ప్రతి ఒక్కరికి కూడా కార్బన్ గురించి ఐడియా ఉండే ఉంటుంది. సో దట్ థర్డ్ వన్, ఆక్సైడ్స్ ఆఫ్ కార్బన్. Oxides of carbon. So here that oxides of carbons are of two types, CO and CO2, carbon dioxide. CO is the most dangerous gas. When compared with carbon dioxide, because during the respiration process that CO is involved, then carboxyhemoglobin is formed. So actually during the respiration in our body, that oxygen will combine with hemoglobin to form oxyhemoglobin. So here oxygen is supplied to the each and every muscle in our body by oxyhemoglobin. But whenever we are inhaling carbon monoxide along with oxygen, that carbon monoxide will form carboxyhemoglobin. Carboxyhemoglobin. So this carboxyhemoglobin is 300 times more stable. 300 times more stable than oxyhemoglobin. Oxyhemoglobin. That is most dangerous one. Because the supply of oxygen in the muscle decreases. Why? Whenever we are inhaling carbon monoxide along with oxygen, both will enter into the lungs. Then immediately that carboxyhemoglobin will be formed, which is 300 times more stable than oxyhemoglobin. As a result, that oxygen levels in the muscles decreases. That's why the supply of oxygen will be reduced. So ultimately it causes various health hazards. Let us take that burning of eyes, vomiting sensation, and even high level will cause the coma or even death. So the presence of CO level in atmospheric air will be very dangerous. Actually that CO will be released in atmosphere from vehicles. CO will be released from vehicles by burning of fossil fuels. So generally we can use fuel in the vehicles. That carbon monoxide level will be present in exhausted fumes. That exhausted fumes of vehicles releases carbon monoxide. So that carbon monoxide will causes harmful effects to the human being. That's why we can use catalytic converters in the vehicles. What is the purpose of usage of catalytic converters? Here some metals like platinum, palladium, rhodium, platinum, palladium or rhodium are used in catalytic converters. Catalytic converters. So these metals are incorporated on the exhausted fumes area. What happens? These can catalyze the released carbon monoxide into carbon dioxide. So whatever may be the carbon monoxide released from the vehicles will be converted to harmless, because CO is more dangerous gas. Already we mentioned in the earlier when compared with CO2. So now that CO is converted to CO2 by using the catalytic converter. And also these catalytic converter can also convert that oxides of nitrogen. Let us take NO or NO2 or NOx, we can write. Those are converted into N2, because N2 and CO2 are not much harmful as like that of CO and oxides of nitrogen. So this is the major part that can be takes in the automobile industry. So in vehicles, that platinum, palladium or rhodium can be used as catalytic converters, which converts that harmful carbon monoxide or oxides of nitrogen into harmless carbon dioxide and nitrogen. So this one is the one more important point. And coming to the second one, that oxide of carbon dioxide. So carbon dioxide is also another oxide of carbon. What is the main drawback of this carbon dioxide in atmosphere? So everyone has an idea about global warming. What is it? Global warming. So global warming is calm. Global warming, or we call it as greenhouse effect. Greenhouse effect. So global warming or greenhouse effect is mainly due to carbon dioxide released in the atmospheric air. Actually 0.03% carbon dioxide will be present in the atmospheric air naturally, 0.03%. But nowadays that concentration or level of CO2 in atmospheric air increases due to some industries and vehicles, especially cement industries. What happens? In cement industry, that limestone can be used, limestone. So that limestone decomposes to give CaO solid along that carbon dioxide. That CaO solid is nothing but quicklime. So along that quicklime, so quicklime is the major requirement for the cement industry. Along that carbon dioxide gas is released, that will be enter into the atmospheric air. That's why the CO2 level in atmospheric air will be increases. So that's why that CO2 will cause global warming or greenhouse effect. What is meant by global warming or greenhouse effect? For example, this is the earth. Okay. So from this certain region atmosphere is there. Here that sun rays will fall from sun to fall on earth surface. That fallen radiations are absorbed by the earth mostly 75%. That remaining 25% are reflected back. Remaining 20% radiations will be reflected back like that. Okay. This is the natural phenomena takes place. But because of the presence of these gases, especially carbon dioxide, along that some more gases are also there. So which is the major greenhouse gas? Carbon dioxide is the major greenhouse gas. Along that carbon dioxide, the other gases are that greenhouse gases are major greenhouse gas is carbon dioxide, along that CFCs, chlorofluorocarbons, along that ozone, nitrous oxide, marsh gas, that is nothing but methane, along that water vapor. Water vapor. All these are greenhouse gases. All these are greenhouse gases. Among them, which is the major greenhouse gas? Carbon dioxide is the major greenhouse gas. So, the presence of these gases will prevent the back radiation. So, the fall of sun radiation on the earth takes place and that reflecting rays will be absorbed by these gases. That's why the surface of the earth will be heated due to the striking of these radiations around the earth. Gradually that surface of the earth will be heated up. So the gradual rise in temperature around the earth is nothing but greenhouse gas, greenhouse effect. So this causes major damage to the earth in different ways. So that will be discussed later. So first of all, what is meant by global warming or greenhouse effect? Due to the presence of some gases like carbon dioxide is the major greenhouse gas, chlorofluorocarbons, CFCs are nothing but chlorofluorocarbons, ozone, nitrous oxide, methane and water vapor are the major greenhouse gases. Presence of these gases will avoid the back radiation. That's why the surroundings of the earth will be fulfilled with sun radiations. Gradually the surface of the earth will be heated up. That's why the temperature of the earth increases. This phenomena is nothing but global warming or greenhouse effect. So, what are the consequences or effects of greenhouse gases? So, that consequence of greenhouse effect is nothing but different way. First thing, with the rise of temperature, that ice in the form of glaciers in Arctic and Antarctic will be melted. That's why that the level of the sea increases. With the increase of sea level, the coastal areas will be submerged. Coastal areas will be submerged. That means that lower areas will be submerged by the seawater. That's why various diseases will be attacked. That means waterborne diseases like malaria, cholera, typhoid, like that. And crops will be affected. Whatever may be the green fields that are present in submerged areas, those will be affected by the flooded water. This is the major greenhouse effect by global warming. How can you reduce that global warming? The major important question is, how can prevent the global warming? How can we prevent the global warming? So global warming is prevented by reducing the carbon dioxide level in atmosphere. So we can reduce the carbon dioxide level in atmosphere by plantation. So everyone has idea about photosynthesis. During photosynthesis, carbon dioxide level decreases and oxygen level increases, because plants will take carbon dioxide and they prepare food, carbohydrates, At the same time, oxygen will be liberated in the atmosphere. So, growing of plants is the best way to reduce the greenhouse effect or global warming. That means afforestation must be takes place by preventing the deforestation. So, nowadays, various forest will be removed due to industrialization, but it cannot be balanced by growing other plants in somewhat other places. So that's why that CO2 level gradually increases due to the deforestation, one thing, and due to the increase in cement industries, due to the burning of fossil fuels, everything will be responsible for the release of carbon dioxide level in the atmosphere. So by reducing that CO2 level, then only we can reduce the global warming or greenhouse effect. So this is the major prevention for the decreasing level of carbon dioxide in atmosphere. After that, one more effect is there in gaseous pollutants, that is acid rains. Acid rains. So acid rains will be mostly identified in industrial areas. Those acid rains are not only limited to industrial areas, they can be also spreaded to other areas, because whatever may be the gases that are present in the atmospheric air which causing the acid rain will be moved to different directions by wind. That's why away from the industrial areas also acid rains are present. Actually, carbon dioxide is naturally present in the air. That's why what is the pH of rainwater? అని కనుక క్వశ్చన్ కనుక వేస్తే that pH of rainwater is equal to 5.6. So if pH is 5.6, then it does not indicate acid rain, because normally that pH of rainwater is 5.6. Why it is not 7? Because normally carbon dioxide is present in the atmospheric air. That water will combine with carbon dioxide will produce carbonic acid H2CO3. That H2CO3 on ionization produce H plus and CO3 minus 2. So without acid rain, the pH of rainwater is 5.6. Because of the presence of H plus ions in atmospheric air, due to the formation of carbonic acid. Now coming to the pH of rainwater due to acid rain. Is less than 5.6. So this is the correct one. So pH 5.6 indicates no acid rain. If pH is less than 5.6, that indicates acid rain pH. Because acid rains are mainly due to the atmospheric sulfur dioxide and nitrogen dioxide. The presence of these gases in atmospheric air will produce acids. Let us take oxygen and water. It produces sulfuric acid H2SO4 and HNO3. So the presence of sulfuric acid, nitric acid along with water will cause the acidic nature to the rainwater. That's why we call it as acid rain. So mostly these acid rains are predicted at industrial area, but they are not only limited to industrial area. Due to wind motion, they can move to other than industrial areas also. So along that rainwater, these acids will be fall. That's why we call it as acid rains. For that acid rains, the pH value is always less than 5.6. If pH is 5.6, that is the normal water pH, normal rainwater pH. If pH value is less than 5.6, then it is acid rain's pH. Okay. So what are the effects that are observed due to acid rain? First thing is marble buildings will be affected. Marble buildings will be affected. Marble buildings will be affected because marble stone contains calcium carbonate. During that fall of acid rains, let us take sulfuric acid. It produces calcium sulfate along that H2 and CO2. That calcium sulfate appears as a black spots. For example, in our country, Taj Mahal is the one of the beautiful place. That Taj Mahal is constructed by the marble stones. Those marble stones contains calcium carbonate. So, due to the release of sulfur oxides and nitrogen oxides around the Agra, that acid rains will be formed, will be surround the Agra. That's why due to that acid rains, that marble stone will be affected to give black spots. That's why the glaze of or beauty of Taj Mahal will be, shine will be decreased day by day. So not only that, so where the marble buildings are there, those marble buildings are mostly affected by the acid rains. That is the one of the most dangerous thing. And second thing is that aquatic life will be affected because due to the fall of these acids in water, ultimately the pH of water will be changes that will causes harmful effect to the aquatic life. So these two are the main drawbacks of the that acid rains. So all these belongs to gaseous type pollutants. This is the one of the gaseous type pollutants in air pollution. And one more thing in air pollution, that particulate matter. What about that particulate material? Already we have discussed or tell that dust or mist along that particulate pollutants. Those particulate pollutants, let us take smoke, smog, dust, mist, fumes. All these are particulate pollutants. In that, smog is the major effect. Smog will be obtained by combination of smoke and fog. So smog will cause mainly very dangerous particulate pollutants because here that smog is of two types, majorly classical smog and photochemical smog. Smog is of two types, classical smog, and the second one is photochemical smog. Actually, that classical smog occurs in atmospheric air while cold humidity air. This one has reducing nature, that's why it is also called reducing smog. Reducing smog, or we are also called as London smog. So here the pollutants which are present in the atmospheric air will be mixed in presence of that cold humidity air, and those pollutants has a reducing nature. That's why we call it as reducing smog or London smog. And another thing is photochemical smog. So that photochemical smog are hot and sunny air which has oxidizing nature. That's why you call it as oxidizing smog. Mostly it occurs in sunny and hot areas. So especially photochemical smog is the most dangerous because here hydrocarbons will be involved. Hydrocarbons in this, that hydrocarbons, ozone, these will form another type of pollutants like PAN, peroxy acetyl nitrate, shortcutly PAN, peroxy acetyl nitrate. So while writing the formula CH3CO double bond 1, peroxy, this is the peroxy bond, acetyl group, CH3CO group is the acetyl group, peroxy acetyl nitrate bond. And acrolein, another important pollutant, acrolein. CH2 double bond CHCHO. This is the formula of acrolein. Along that formaldehyde, HCHO. So all these indicates photochemical smog. So these photochemical smog will cause the health hazards to the human being. So these will be available in atmospheric air. In sunny areas it is available. So due to this, that respiratory disorders will be obtained in human beings. Not only that, buildings will be also affected due to these photochemical smog. That paints will be affected by these chemical smogs. That's why they becomes very dull. So all these type of photochemical smog and also previous one classical smog will be under the examples of that particulate pollutants. So mostly questions will be asked from photochemical smog and also classical smog. So these points are important for examination purpose. Along that we can know the structures of that PAN and acrolein along that formaldehyde. So here ozone is also a photochemical smog, especially it is present in troposphere. If it is in a stratosphere, it is helpful to us because it absorbs the UV radiations which are coming from the earth. Okay, so all these under the category of atmospheric pollution, air pollution. So atmospheric pollution is divided into four categories. Among them we are discussed the first one, air pollution. So after that we have two pollutions are there. One is water pollution and third one is soil pollution. Actually that fourth one, that is sound pollution, is not beyond our scope. So two more pollutions will be left, that is water pollution as well as soil pollution will be discussed later. సో ఇప్పటివరకు అయినటువంటి వీటి వరకు ఒక్కసారి పాయింట్స్ అవి అన్నీ రిమెంబర్ చేసుకొని ఏమన్నా కనుక క్వశ్చన్స్ కనుక ఉంటే నెక్స్ట్ క్లాస్లో మనం డిస్కస్ చేద్దాం. ఓకే.